Okay, hello everyone, and welcome to this session of Bioinformatics Bootcamp. My name's Henry Miller, and I'm going to be your primary instructor. We have two TAs, Simon Levy and Dan Montemayor. They're going to be helping out as we go along here. So let's go ahead and kick this off by talking about how to download R and RStudio. So the very first thing you're going to want to do is you're going to want to go and Google download R. And when you do this, you're going to find the R project for statistical computing. So you come over here to the R project for statistical computing. You go to here where it says download, pick cloud, and then pick the one that's right for your operating system. For Windows, just download base. For Mac, just download this very first thing, R 4.1.0.pkg. Go ahead and install these, and that will get R onto your computer. You can accept all the defaults. Nothing special needs to be done, okay? Now, the next thing you're going to do is download RStudio. So go over here, search RStudio, download. Come over here, choose the free version of RStudio Desktop. Go ahead and click the button that says download. It should detect your OS automatically, but if it doesn't, then go over here and download the correct one for your operating system, install it, accept all the defaults, and then when you open it up, you should see this. To verify it's working, you can come over here and print hello world. All right. So now this shows that our RStudio are working. Before we move on, has anyone not gotten this to work? Is anyone not seeing the same thing I'm seeing here? If you are having trouble getting to this part, please put it in the chat and we'll make sure to stop, go back and help. We want to make sure that any issues that arise end up in the video so that other people who find the same issues at home can see how we solve them. Okay. Now, what you're going to want to do to actually get the course materials is you're going to want to go to our website. That's bigbioinformatics.org. It's bigbioinformatics, all one word.org. Come over here to workshops, R for IBMS pre-mat. And this is going to have the syllabus, the GitHub workshop repository, and all the lecture videos and course materials as we go along will end up here. So very first thing, go to our GitHub repository. I'm going to put this in the chat just to make sure everyone's got it. Go ahead and download the zip file for today. Extract it, and you should see this once you extract it, right? Oh, sorry, you should actually see this once you extract it. Come in here, go to module 1, and now that you've got RStudio installed, you should see this icon show up on this .rproj file. Go ahead and double click on this .rproj file to open it up in RStudio. All right, well, apparently that is struggling. Come on, you can do it. Windows 11, there you are. And you should see something that looks like this. Okay, so what you're going to want to do is open up the R for Biologists Part 1.R script. Just go ahead and click on that, and you should see this. Now, what we're going to be doing today is we're going to go through some R basics. Now, you've all done the data camp, or at least most of you have. So very good work there. That was very hard to get started with. It's quite a bit of a challenge when you're first starting, but hopefully data camp smoothed out a little bit of the process of getting going there. What I want us to do today is to review the basics from intro to R, intermediate R, and start talking about what you're going to be doing in the next section, which is where we're going to go through the data science concepts from the tidyverse and get started on the project for this workshop. The main purpose of this workshop is really to get you into that project, get you working with some biological data, and ultimately get you an independent project that's not only going to get your bioinformatics portfolio started, but actually make a great talking point as you start talking to PIs and showing them what you can do. Okay, so before we jump in, any questions on this so far? Has anyone not gotten to this point at this time? Anyone not seeing the same thing that I'm seeing here? Okay. Well, if you've got any questions, do please put them in the chat. Okay. So, okay. So Kate said she was having a bit of a trouble opening this up in RStudio. Kate, can you tell us, is it, you're saying you're having a hard time opening this R project, this .rproj file? Okay, so do you have were you able to get RStudio installed? Okay, so again, close this out. All you got to do is go to where you downloaded the code. So do you have the code downloaded and unzipped? Okay. Okay, so that's what you got to do. You just go to our bigbioinformatics.org, come over here to the workshop. So this has a link to our GitHub repo, right? So right here, you download the code where it says download zip. So that's just where this download button is. It says code, download zip. And that's going to download the zip file. So you just go ahead, extract that. And that should give you this right here. You click in and you should see this .rproj. And when you see this, you just double click on that and that will open up RStudio. Takes a second, apparently. Oh, there we go. Did it twice. There we go. And then once you do, you should see this. All right. I want to go slow through this. I want to make sure everyone is on the same page because this is just really the sort of baseline we're going to build from here. So I want to make sure that everyone is able to follow along with this. If you've got questions at any point, please do ask them. This stuff is really hard at first. I mean, truly, this is a huge challenge, especially if you haven't worked in a coding environment before. So I want to make sure that we're taking the time we need to take to make everyone feel comfortable with the material. All right, because when we start that project, you're going to be expected to do a lot of this stuff on your own without our help. At that point, it would be best if you feel comfortable with the sort of basic process of setting up R and RStudio and opening it up like this. So if you have any questions, please do ask them. Even if you feel like they are simple questions, they'll help someone else who didn't feel comfortable asking. So it really is a huge benefit when you ask questions. All right, so to open up that script again, you just come here, click on this, and now you've got your R script here. Now, one final thing that I did not mention, but it is imperative that you all do it before you begin. In fact, R will not function at all unless you do this. You just got to come over here where it says tools. All right, you see this tools, global options, appearance. And what you're going to want to do is come down here and find just a really nice dark theme for RStudio. You're going to have to find a really nice dark theme for RStudio. It legitimately will not work without it. It'll make you restart, apparently. Didn't used to do that. But now it works. You can see it works just fine. I'm obviously joking, but you know, people can tell you're a real coder when you use a dark theme on your IDEs. So want to seem fancy. I'm just joking. Obviously, pick whatever theme you find easiest to work with. I like this one. It's called Monokai. And I personally enjoy having things in dark theme because I feel like it's easier on my eyes, but some people like light theme better. So yeah, as Simon says, congrats, you're now a hacker. Corey asks, how did you get the R for Biologists file on the top left? So let me go ahead and close this up. All you have to do is come over here and click on this. See, it's right here in your file panel. So all you got to do is click on that and it opens it up. You can also come over here where it says file, open file, and then you could click on that script, open. Okay. All right.
Can you please show us again how to change the theme?
Sure. So where it says tools and in the top panel, tools, global options, appearance, and then you can pick one of these editor themes. So you just got to pick one. There's a lot of different kinds. Pick whichever one you like. You can even add new ones if you get them custom made or custom downloaded. I like this one, Monokai. That's like my favorite. It's the one I always use. And then you just hit apply and it'll change your theme. All right. All right. Anyone having issues? So Kate mentioned getting an error starting R. You shouldn't be trying to start R. You should be trying to start RStudio. Are you saying you're getting an error starting RStudio? What is the error you're getting? Okay, so that means that you downloaded the wrong version of RStudio. So, okay, so the error that Kate is getting is Arch unknown architecture ARM64. That means you downloaded the wrong version of RStudio. So make sure you go back and find the one that's correct for your operating system. So if you come back here to where the RStudio download pages. Oh, so first of all, are you on Mac or Windows? Okay, well, so you just come over here to download and make sure that you pick the one that is correct for your operating system. Okay. Although, are you on Mac or Windows? Oh, you updated your OS when you restarted your computer. Ah, okay. So is that Mac then? Or Linux? Well, anyways, so was it Mac or Linux? Okay, well, I'm just going to move on. All right. So hopefully Simon or Dan, maybe you can help. Okay, you had Catalina, now you've got Big Sur. Okay. All right. So yeah, that might have something to do with it. Yeah. So if you re-download it, yeah, okay. So Giovanni suggests Catalina wine mixer. So Big Sur, it should work though, right? Do other people here have Big Sur? Mac stuff confuses me, to be honest. Okay, so yeah, if you go back and re-download the RStudio, it should now download the correct version for Big Sur. Need to re-download. Okay, perfect. Perfect. Yeah, so I hear people saying it was the second option. So it should be this one here then. Very good question. All right, well, go ahead and try re-downloading and reinstalling that. And if you're still running into issues, let's come back to it, because this is such a case-by-case sort of thing based on the type of computer you have, the type of OS you have. It's one of the things that makes me not want to use RStudio on my personal computer. But since none of you have a server that you have access to yet, it's kind of the only option that's available to you. It's also the option that most people will use most of the time, to be honest with you. All right. Just so you all can see what I've been like alluding to, this is what RStudio server looks like. It looks the same, except that you do it in your browser. So the difference being that I'm running R on my computer, and with RStudio server, R is actually running on a different computer that is not mine. And I can connect to it from anywhere, from any computer. It's very, very convenient. And it's running on Linux, so it's not actually running on Windows. Anyways, don't have to worry about that though. Let's go ahead and jump into the script. So a few concepts about RStudio just to begin here. first of all, you have the script, you have the environment panel, you've got the files, plots, packages, help viewer, and you've got the console. Let's just focus for right now on only the console. The console is the workhorse. The console is really where you're interacting with R. The rest of it is just stuff that helps you out. The console is where things actually happen. Okay, so in the console, we can run arbitrary R code. We can print hello world, for example. So everyone go ahead, make sure this is working. You're able to print hello world and get a response. All right. Now, the console is very powerful, but it's very inconvenient to work with. We're typically writing analysis scripts. They contain many steps and they're very complex. You don't want to be writing them one line at a time in your console like this. That would take forever and it would be honestly terrible practice. The better way is to have a script that you can work on. So go up here and open the script part up now. So scripts are basically just a text file like you would make in Notepad or WordPad or even in terminal editors like Vim or really, I don't know what's on Mac. Whatever the one on Mac is, that's like Notepad. It's really, that's all it is. The only difference is that it's got this highlighting that helps you code. So it kind of tells you what is what. The highlighting is just a thing that makes the human more capable of reading their own code. The other thing is that you can execute code arbitrarily from your script in the console. So what I'm going to do is I'm going to take line 8 here, and I'm going to click this run button, okay? All right, so what that did was it took line 8, it basically copied it, pasted it into the console, and executed it as R code. All right, so it takes the text, copies it into the console, and executes it. And that's what happens when you hit this run button. And you can see as I keep hitting the run button, it steps forward line by line, copying it into the console and executing it. Now, I personally find it very annoying to click this run button. So instead, I just use the keyboard shortcut, which is Control Enter or Command Enter if you're on Mac. Control Enter, Command Enter. Okay. RStudio is really just a productivity tool. It's just something that makes data science much easier, makes your workflow much easier, and ultimately gives you a way of seeing your data that you can't really get when you're just working on the console as easily. So just remember that it's just a way of interacting with R. I could just as easily go into the command line and do this. I could just as easily pull up a different editor such as VS Code or PyCharm or Jupyter Notebook and do the same things. It's just the editor. This is the editor. The editor is just a way for you to interact with the console, right? You could do that. You could do that in many ways, though. It doesn't have to be through RStudio. I prefer RStudio. Okay. Any questions so far before we actually jump into the R part? We'll get to those last two panels later on. I just want to focus on what is simpler for right now. Okay, well, let's jump in then. So you all did the introductory, intermediate, and most of you did tidyverse, I think. But I want to just go through some of the concepts from the introductory and then the intermediate today, and then tidyverse will be next time. Okay, so we're going to review these things and go on to the project. So I want to start off with basic concepts about data structures in R. R is, in my opinion, the superior language for data science. And the reason I believe this is because R is really a specialized tool for data science. It's not a very good general purpose programming language like Python is, but what it is excellent at is the way that it allows you to store, manipulate, model, plot data. That's what it does really well. And the reason is because of its data structures. So we're going to begin by talking about those. We're going to talk about the simple kind, we're going to talk about the more complex kind, and then we're going to talk about how you can perform operations using them. All right, so the first data structure you want to talk about when you're talking about R is numerics. And that's because that's sort of the root of pretty much all the mathematical work you'll be able to do in R. So numerics are numbers. They contain number data. They can be integers, such as 1. They can be, scientific shorthand, such as 1E100, 1 times 10 to the 100th. And they can be floating point decimals, so 1.1. So just decimals. Okay. You then have logicals. Logicals can only be true or false. So they're a binary data type in R, true or false. All right. So you've got true, all caps TRUE. And you've got false, all caps FALSE. Anyone who remembers the data camp introduction to R, can anyone tell me a alternative way to say true or false? Go ahead and put it in the chat if you know it. So Boolean, so I mean, literally though, if I wanted to say true, is there another way I could say true?
Like 0 and 1?
Sort of. Okay, do they not go? I don't think they go through this in data camp anymore then. Okay, you've all got some very complicated ways to do this. A lot of them are correct. Lydia, yeah, exactly. T or F. So R for some reason allows you to just put a capital T, and that also means true. Or capital F, and that means false. Yeah. Don't really know why they let you do that, but they do. It's not very good practice, but it's something that you can do. All right. Can anyone tell me what would happen if I tried to run TRUE as in Python? Sorry, it's already trying to like correct me, as in the way Python does it. Can anyone tell me what that will do? That's right. It'll give an error. Very good, Shad. All right. Error. Object true, not found. Okay, so that basically means we tried to get R to process an object that did not exist. Okay, so R case sensitive. Keep that in mind. All right. All right. Simon makes a really good point that the type of variable that encodes true or false is a Boolean or a logical variable, and it can be read as a 0 or a 1 for true and false. We sort of talking about how it's encoded at the sort of machine level, right? We'll get to in a second, though, what it means to be a certain type of object. So next up, we have characters. Characters contain string data. So it could contain a phrase like a sentence. It could contain a name. In this case, we have hello world. And this is a string. Okay. So pretty basic stuff, all stuff you covered in data camp. All right. So objects in R, or data types in R, data structures in R are types of objects. In fact, everything in R is an object. That's why we call it an object-oriented language. So how could you tell what kind of object you're dealing with? Well, you could use the class function. So this is a function called class, and anything you put inside of it, it is able to determine the type of object that is. So class of hello world, character, is an object of the character class. Class of 1, numeric. 1 is an object of the numeric class. Class of true, logical. That is the name of the logical class. So while we refer to these as Booleans, the technically correct name for it is logical. Okay. Now, objects don't just have a class. They also contain data. And that's really what makes an object in R, is data and class. The data component of an object can be revealed using the str, which stands for structure function. So structure of hello world, we see CHR, that's shorthand for character. So it's telling you the class, and then it's saying what data is contained inside the object. So it's a little bit redundant. It's a very simple object type, so you're not really seeing much more than what you could already discern by your eyes. But basically, it's telling you here it's a character that contains this information. 1, numeric, that contains this information. True, logical that contains this information. All right. Here's your first challenge question. What is the class of str? Let me have a second for people to try that out on their own before I say. Okay, yeah, it is a function. It is a function, Hector. Very good. Very good. So you can test this by doing class of str. Function. Even functions are a type of object in R. So everything's an object, even functions. Now, some of you might have tried to do this because R probably prompted you, or sorry, not R, but RStudio probably prompted you to auto correct to this. That produces an error. And the reason is because unlike without the parentheses, this indicates that you want to actually call this function. It means that you want to actually run the function, but you didn't put anything inside of it. So for example, this would be the equivalent of me doing this. Again, I get the same error. You'll run into errors a lot as you're first beginning. And when you run into them, basically the reason 90% of the time, the reason is going to be because you haven't yet understood how R works behind the scenes. And you don't yet have a feel for the syntax of it. And that's okay. You'll learn that with time. The other 10% will be like legitimate errors that you will have to figure out. And at first it'll be frustrating, but it's okay. It's just part of the learning process. You'll get to the point where you experience few errors. And when you do, you have a pretty good sense of why you got them. It just takes time to get there. Okay. So from there, let's go ahead and move on to our first set of methods for simple object types. With numerics, you can do mathematical methods. Okay, so we have addition, subtraction, multiplication, division. We'll start running these. Division, exponentiation, so that's 2 to the power of 3. Modulo, which is just the remainder after a division. So when you divide 10 by 3, you get a remainder of 1. So the modulo, so 10 modulo 3 is 1. And then you have PEMDAS. So PEMDAS just refers to the order in which operations are carried out. Okay. Quick challenge question. What is the remainder of 14 divided by 3? And solve this with R. Don't do it in your head. Okay. All right. So can anyone tell me what line of code you would run to get the answer to this?
The modulo 1.
Right. Well, but specifically what, yeah, okay, exactly. Yeah. Very good. 14 modulo 3. This is the remainder of 14 divided by 3, which is 2. Very good. Very good. Okay, so those are mathematical operations, very basic ones. Let's talk about logical operations now. Okay, so logical operations are fairly straightforward, especially if you've taken any sort of quantification of logic before or formal logic courses before. Basically, logicals can only be true or false, so they're a little bit more straightforward with how they can turn out. The first that we'll talk about is the not operator. So not just negates the value of a logical. So if it was true, it becomes false. And if it was false, it becomes true. All right. The and operator acts as a kind of gate, if anyone's heard of an and gate before. Basically, this is an assertion. I'm saying here, I'm asserting true and false. And when you make an assertion, you're always asserting that it is going to end up true. Okay, so you're asserting that this will evaluate to, or sorry, that this and will evaluate to true. And only evaluates to true if both the left side and the right side are true. Okay, so that's what makes an and gate. This is false because one of the two sides is false. If I switch this to true, it would now become true. Likewise, if I switch this to false, now it becomes false. All right. Hopefully that makes sense. So Daniel says he's still having issues. Can you be a little bit more specific? Okay. So let's talk about or while Daniel's describing the issue that he's running into. Okay, so or is going to evaluate the true if either the left or the right side or both is true. All right, so the left side of this statement is true, so therefore the whole thing is true. If we made both of them true, it would all be true. Can anyone tell me the one way to make an or evaluate to false? There's only one way. That's right. Exactly. If they are both false. The only way, yeah, exactly. They would both have to be false. Now the whole thing is false. Okay. All right. So can anyone tell me what true and exclamation point false evaluates to? Okay, good. Good. In fact, it is true. So if we type, and that's because before you evaluate the and, this right side gets evaluated. So not false. What is not false? Well, that is true. So this whole thing is just the equivalent of true and true, which of course is true. So I can verify this by taking this, pasting it in the console, running it, and I can see it is in fact true. Just like in math, there's an order of operations in logical operations as well. I'm not going to belabor the point for the sake of time, but if you're really interested, go ahead and look it up. It's fairly uncommon to have complex logical operations in your day-to-day coding. So I'm not going to belabor that point, but it's honestly kind of fascinating. If you ever have a chance to Google what's the operation order for logical operators in R. All right, one final point I'll make here is the difference between a single and a double and. So a single and evaluates both sides at once as logicals. A double and does them in order. So it's kind of a funny thing that can happen. This evaluates to false, but this produces an error. And all I did was change the false to true. And the reason is because if this encounters a false, it just stops evaluating. So it never gets to the hello world at the end. It never realizes that's not a logical. It never gets confused because it stops after it sees the false. Because if there's one false in your and statement, that means that by definition, the whole thing has to be false. So it just stops here. So also the reason that that this will produce an error. But you know, again, this won't. Anyways, kind of arcane stuff. I find this sort of thing really fun. It's the sort of thing that you'll begin to appreciate more and more as you become more comfortable with R. All right. Finally here, let's talk about some variables. So variables are just names that you give to objects. So I'm going to give this object 1 the name A. We call this operator the assignment operator. So this basically says I want A to be a name referring to the object 1. Okay, so I assign A as 1, I assign B as 2, and now I can use A and B as stand-ins for 1 and 2. The question is, why would you want to do this? Why not just do 1 and 2 directly? Why not just use them and add them together directly? Well, the reason is because as you do more and more complex operations and you start to use functions, you'll see that variables are basically required for so much of what you'll need to do in the language. And this enables you to do some very complex things. Now, you can also have names on your variables. This is actually not exactly, this is technically correct, but this is not really accurate. So this is actually something that I wrote back when I didn't have a complete understanding of how this was working. So just ignore that I said this. It's not variables that can have names. They can have names, but that's not really what this is doing. Variables are names referring to objects. Let me just delete this. Variables are names referring to objects. So for example, I could refer to the statement true or the Boolean true with the name went to store. So let's say went to store is true, bought cheese is true. The evaluation of went to store and bought cheese is now being assigned to a new variable went to store and bought cheese. So what is the result of taking this and sticking it in the console? What would that produce? What would be the result of that? Can anyone tell me? Okay. So, Francine, can you tell me about the error you got? This is a really good one to talk about. Can you tell me about the error you got? Can you copy the exact text of your error into the chat? Yeah, good. This is one of the most important errors to understand as you're beginning. So the error Francine got was object went to store not found. Okay, so can anyone tell me why that object was not found? Because does anyone know? Anyone want to take a guess?
Oh,
Exactly, Morgan. Very good. You didn't run the part of the code that assigned it. So line 68, you got to run it. 69, you got to run that. 71, you got to run that. And only when you've done all those lines are you able to finally execute this. If I take this went to store and bought cheese. Okay, put that in the console. Only when you run all those lines above it. R is running sequentially, right? Everything that you use must have been created by a previous step, or it must already exist in R by default. So for example, you didn't have to create 1 and 2 and 3 and 4. Those are already in R by default. But if you try to use A before it was created, then it will produce an error because it hasn't been created yet. So things run in a sequential order in R. Okay. When you see that error, something not found, that pretty much universally means that that object was not created yet, or that variable was not created yet. Okay, so let's come back to these panels that we were talking about before. Move them over, and now we'll see there's something interesting up here. I see these objects that are listed here in my global environment. Now, this is interesting because these are the objects we just created with, or sorry, these are the variables we just created in R. A, B, went to store, bought cheese, and went to store and bought cheese. I see all 5 of these right here. And the reason is because when you create a variable in R, it will be stored in your quote environment. That just means the objects that you're currently storing in memory on your computer, in the RAM on your computer, right? And so if I make a new variable, let's say that I have a variable called, var. Oh, that's already there's already a function called that. We'll call it my var, and then I assign that as 100. We can see now it ends up in the global environment. This is a very useful feature for RStudio because it helps you keep track of what objects you have created so far. Okay. Really quick point. Now, we use these assignment operators. You can technically also use an equal sign, but it's a terrible idea. So I would really strongly recommend not doing that. You'll see people do that, but that's bad practice. And there's a good reason for it. I don't have time to get into why, but there's a really good reason not to do that. Morgan asked, do you not have to create that in the script? No, again, the script is just a text file. It is just a way to help you write your code. The console is what does everything, though. Ultimately, it's only the console that's really doing anything. So you can write stuff directly in the console. There's really no requirement that you write things in the script, but you'll find as you write more complex analyses, you'll prefer writing in the script and then executing them, line by line in the console. Basically, all you're doing is when you execute the line, it just sends it to the console and runs it exactly like Simon said. It's just taking this line, copying it and pasting it into the console. This is identical to me copying and pasting this line myself and running it. It's the identical thing, or just typing it all out by hand in the console. Identical. So it's really only the console that's doing anything. The script is really just to help you and make the process of writing easier. Okay. One other thing I'll note here. I used a shorthand that I know there's a Mac version of it. I don't remember what the Mac version is, but for Windows people, if you hit Alt minus, it makes that assignment sign in RStudio. Does anyone know the Mac version of that? I honestly don't remember what it is. There's a Mac version of it, but it's extremely convenient. Makes it very easy to very quickly do these things. Option minus. So in Mac, it's Option minus. So Alt minus in Windows, Option minus in Mac. Very convenient shortcut. Something fun that you can do if you feel like it is you can actually do double assignments like this. So this will actually assign X and Y at the same time as 1. See, assigns X and Y as 1. All right. You can also do right-handed assignments. You don't just have to do left-handed. Although this one, I don't know if there's any shortcut for that. I've run out of letters apparently, so I'll just do L. It'll assign all of them at once. There's really no reason to do only left-hand assignment unless it's for convenience sake. It's usually also convention, so you'll scare people who are not more familiar with R if you do right-handed assignments, just so you know. Anyways, arcane stuff that I find really fun. Okay, let's actually move on here. Can anyone tell me if you were to execute this, what the output of result would be? So if you executed these lines 76 through 80, what would result be? Okay, good, good. Okay, good. That's right. It would be true. That's another thing I guess I did not mention. If you highlight all the lines at once and hit Control Enter, it will run them all sequentially at once. Okay. So that's right. It is true. So you can see here. A little bit tougher one. What about this one? What would X be in this case? See if you can guess it without actually running it yourself. Okay, good. Very good. Very good. It is in fact true. And the reason is because, and let's break it down here. The reason is because while flowers and while potatoes is false, therefore this part on the left is false. We have an or here, and the or is to or not bread. Now bread is false, but the not makes it true. Therefore the right side of this will be true. Even if the left side is false, it doesn't matter, because for the or, you only have to have one side be true for the whole thing to be true. All right. So we run this. We see it is true. So it is in fact true. Okay. Before we move on, so one last thing before complex data structures, you can also do logical comparisons. So equals equals, that's just a shorthand for testing equivalence. So that's like I assert that the left side and the right side are the same. They are equivalent values. So left side is 1, right side is 1. These are equal to each other. Therefore, 1 equals 1 is true. We see that here. It is true. What about hello equals world? What will that give me? Okay, so Lauren is right. That will be false. And that's because hello and world are not the same. So when we test the equivalence, we see that they are not equivalent, and therefore we get a false back. False. You can think of this like an assertion. You could be like, this is me saying, I believe, I assert that hello is equal to world. And then someone would say, no, that assertion is not true. That assertion is false, basically. That's kind of like what you're saying here. That's how you can think about it. If I change this to hello, now it becomes true. All right. So you can see how that's sort of working here. Now, not equals is signified by exclamation equal sign. So this basically says left side and right side are not equal. I'm asserting that the left side and the right side are not equal to each other. Now you test for me whether that assertion is true or false, right? And in this case, it is true. Yeah, very good. Very, very good. It's true because the left side and the right side are not equal. Therefore, the statement these are not equal is a true statement. And therefore, we see true here. If I change this to 10, now it becomes false because now my statement they are not equal is a false statement because they actually are equal. So hopefully that makes sense. This is just some more formal logic for you all, quantificational logic for you all. We also have greater than, less than. So those are fairly straightforward from basic maths. Less than or equal to, greater than or equal to. Okay, so next up is complex data structures. But before we get to that, let's go ahead, take questions. Anybody have questions at this point? Anyone feeling lost at this point? Please say something that allows us to help you. And also it'll be a huge help to people who were not able to make it today and who will watch the video later. Okay, well, I'm going to go ahead on then. If you've got any questions at any point, please put them in the chat and I'll make sure that we stop and get to them. Okay. So vectors. Now, vectors are one of the primary objects that you'll use for data science in R. And the reason is because they're very extensible. You can do a lot with them. And they're probably one of the main things you're going to be using on a regular basis. So vectors are just a collection of objects. And so it could be a collection of numerics, a collection of characters, a collection of Booleans. Okay, so to make this collection, you just put a C, parentheses, and then you put inside the items you want in that collection. So 1, 2, and 3 in this case. If I run this line, it prints back to me 1, 2, 3. This is a vector containing 1, 2, 3. This one contains characters, hello world, exclamation point. This one contains logicals or Booleans, true, false, false. So you can use the assignment to assign vectors to variables. You can assign any object to a variable. Can anyone tell me what is the class of high? What is the class of high? Okay, good. It is a character. Just as a quick recollection here, how do you determine the class of something? You can use the class function and put inside of that the thing you want to know the class of, run that, and it will tell you character. Okay, now variables don't have a class. Variables are just names that refer to objects. Variables don't actually have any real meaning in themselves. They're just a name for an object. So variables don't have a class, right? The class of a variable is just going to be the class of whatever that variable refers to. So it would be the literal equivalent of doing this, except that it's easier. It's just the equivalent of doing that, except that you get to not have to continually deal with this sort of complex looking object. All right, very good. You can also make numeric vectors with a shorthand. So this would be the shorthand of 1 through 10, integers 1 through 10. So we see that here, 1 through 10. Sorry, I just used a little bit of a trick I didn't mean to use. If you highlight any portion of our code in the script and you hit Control Enter, it'll run it by itself as if it's its own line. So if you just put your cursor on a line and run it, it'll execute the whole line. But if you highlight a specific portion of the line, run that, that will also run just that portion as a line in the console. You'll kind of pick that as sort of a more advanced trick. You'll pick that up as you go along, though. Now, vectors can have names. This is one of the best features of vectors. They have names. Okay, so this vector contains all right, so someone else who remembers the spiel I gave a few minutes ago, tell Hector, who's just brought up the object something not found. Good. All right, you remember. All right, good. Exactly. You got to make sure that it gets created. You can see if it's been created up here. All right, good. That is the most common error. You will run into it first. So good that you're bringing this up. Very good. Okay. So we assign myvec as the numbers 1, 2, and 3. We execute that. We see 1, 2, and 3. Again, this is the equivalent of just copying and pasting in the console and executing it. So don't be mystified by that. Now, names is a function that we can use to either get or set the names of a particular, of a particular object. So now we're going to call the names as hello world exclamation point. So what do we now see when we print myvec? Well, we see our original data 1, 2, and 3 right here, but we also see that we've given names to each of those data points. Now, the data point 1 has the name hello. The data point 2 has the name world, and the data point 3 has the name exclamation point. This is a bit of a challenging subject for a lot of people at first. But just know that this basically means that your underlying data is 1, 2, and 3, and these have the names hello world exclamation point. You'll see later on why this is really useful. But for right now, just know that this is something you can do. Okay. Next up, how do you get the elements of a vector? So this vector has 3 elements, 1, 2, and 3. Let's get the first one. We use these square brackets. This basically says I want to access this first element, right? We get that first element. This says I want to access the elements 1 through 2. This says I want to access the element that has the name hello. That would be, again, the first element. Don't worry about this challenge problem for 1 second. I want to just come back to this. Let me just further drive home this point. If I say myvec, tell me what could I put in here to access the element with the name exclamation point? What could I put in there to access the element that's got the name exclamation point? Can someone tell me 2 ways to do that? Okay, so that's good. That's one way. Good, that's both ways. Very good, guys. Okay, so that's the 2 ways. So the first way is just to put the 3 in here, because that would be the third element that has the exclamation point as the name. So you can see that there. The other way would be to actually use the exclamation points inside the brackets. So we can see we get the same thing from both of these. There's actually even more complex ways to do it, but I don't want to go into that yet. We'll get to that later. Okay, so that is vectors and how you get elements from a vector and how you set the names of a vector. Now, can someone tell me what is the result of hello world 1? Can anyone tell me what that is? So this would be the equivalent of me taking this, putting it into the console and running it. Can anyone tell me what this will give me? And more importantly, can anyone tell me why? I mean, the hard part of this is why. So I'll just show you what you get. You get hello world back. How can that be? How am I able to use this bracket notation on something that is not a vector? Can anyone tell me why? This is a little bit arcane, actually, but it's an important thing that I wish someone had told me when I was first starting to use R. It's the same reason that hello world has the same class as a vector containing strings in it. So the class of hello world is character. The class of a character vector, my vec, is the same. They're both characters. Why is that? Does anyone have a guess as to why that might be? It's actually because I kind of lied to you a few minutes ago. It's also because people tend to lie to you when they teach you R for the first time. Does anybody have a guess? Okay. The reason is because there is no such thing as just a single character in R. Other languages have this. Other languages have strings. R does not. There's no such thing as a single number in R either. There's no such thing as a single Boolean in R or a single logical in R. These do not exist. They are actually a shorthand that we use. It's a simplification that we use. In reality, there are only vectors. There are only numeric, character, and logical vectors. It's the same reason why true 1 is also true, and why 1 is also 1, because 1 is actually just a length 1 numerical vector. It's the equivalent of me doing this. They are the same. So you will find over time that this becomes very important to understand about R. So try to remember it now. There's no such thing as numerics, logicals, and characters in isolation. They are always length 1 numeric, logical, and character vectors. Again, true 1 and hello world are the equivalents of true 1 and hello world. All these are equivalent to each other. Okay. All right, that's getting a bit arcane, but it's just really important to understand as you get better and better at R. All right, any questions about what we've talked about so far with vectors? Okay. Let's start moving on a little bit here where you've got a lot to get through and not a lot of time to get there. I'd like to get you far enough to get to the homework though, so we'll go a little bit faster here. If you got questions, put them in the chat and I'll try to get to them at the end. All right, so the next one that's up is the data frame. Now, data frames are the workhorse of most of the data science you're going to be doing besides vectors. Vectors are very important, but data frames are really how you deal with data on a day-to-day basis typically. It's kind of like your Excel, but a lot more powerful. So data frames, and we'll just see one created here. Data frames are tabular data sets, right? So this contains numerics, characters, and logicals, right? And you can see these are your columns, as in Excel again. These columns have names, numerics, characters, and logicals, and these you can see how we assign them up here. The rows also have names, and that's how we created them here with the row names argument to the data.frame function. So this will start to make more sense as we work more and more with these, but just know this is how you can construct a basic data frame. You'll rarely do this in practice, but this is just for right now, as you're learning, this is how you can make one on the fly. Now, when you create a data frame, it does get added to your environment here, but there's something special that happens because this is a more complex data structure now. You get the option to come over here and click on it and view it. This is something special about RStudio. It allows you to take this nice tabular view of your own data. You can sort it. You can filter it. Just like you can in Excel, you can search for terms. So if I search for world, it just brings up the row where world is available. Anyways, all useful stuff you can do. You can get the row names of a data frame with the row names function. You can get the call names with the call names function. You can also set the row names as something else and the call names as something else. Again, using vectors to prescribe these. You can also use the view function to view data frames in RStudio. That's actually what we just went over. Clicking on this is the same thing as using the view function. So when I click on it, you can see it actually copies and pastes that command into the console and runs it. So it's an RStudio function, very useful. All right, so similar to vectors, you can get the elements of a data frame using indices. You can use numerical indices using square brackets. Now, the way that data frames work is you give the row, then you give the column. Okay, so row, comma, column. So if we wanted the element in row 1, column 2, we do 1, comma 2. In this case, row 1, column 2 is hello. Row 2, column 1. Can anyone tell me what that would be? Can anyone tell me what row 2, column 1 would be? Good. Row 2, column 1, row 2, column 1 is a 2. Very good. Now, when you don't specify anything here, that means take all the columns, right? If you don't specify a specific column, it means take all the columns. So we're saying row 3, all columns. And you can see it returns it as a slice of the data frame. So likewise, you could take all rows within column 2, but it returns it as a vector. This is something important to notice. When you take all of the columns, it'll return it as a slice of a data frame. So it still returns a data frame when it gives it back to you. But when you take all the rows within one column, it gives it back as a vector. Just little things you'll have to watch out for as you start to get more and more familiar with R. These are just quirks really of R. Just like in the vector world, in the data frame world, you can use the names of a column or a row in order to access the values. So this time we say, instead of using the numerical index, we actually use the name of the row. So we have row 1, column 2. Again, row 1, column 3. Row 2, column 1. I'm just going to go a little bit faster through this. And row 2. Now, a final way is to use the $sign. This is probably the most common way you'll often do this. So when you use the $sign, this is another way of saying access everything in a particular column. This is only used for columns. You can't use this for rows. So this gets everything in column 1 and it returns it as a vector. So $sign is kind of an interesting operator. If you open it up in RStudio, you can see what options you have to work from. And they just hit enter to select the one you want. And then once you return it as a vector, you can get the second element of that vector. And that's a very sort of simple way to get a column as a vector and get a certain element of that vector. All right. So let's go on here. What is the, can you make a data frame where all the columns are not all the same length? So really quick, can anyone tell me what the answer to this question is? And if you want to, go ahead and try it out, see if you can find out the answer. So the question is, can you make a data frame where the columns are not all the same length? My cat's coming to say hi and learn how to do R. Okay, sorry for picking you up. All right. So Shahad got an error. Did anyone else get an error? Lauren, I'm guessing you also got an error. All right, let's try this out. Let's see what happens here. Easiest way to do this, copy and paste what we had before and just alter it. You don't want to work harder than you have to. That's like a thing I'm going to say a couple times, but don't work harder than you have to. There's really no reward for doing that. All right, so now we've got 4 elements in this one column, but 3 in the others. Okay, good. That's what you did. Good. Never work harder than you have to. We got an error. And what did our error say? It said arguments imply differing numbers of rows, 4, 3. This is R telling you exactly what went wrong. You tried to make a data frame, but one of your columns had 4 rows and the other ones specified 3 rows each. Okay. And so that's what happened. And so R is telling you here. So don't be afraid of these errors. The errors are trying to help you as much as they can. Sometimes they're a little bit confusing, but in general, they're trying their best to help you out and see if you can learn from what the error says, what might have gone wrong. Very good. Very good. Moving on. Lists. So lists can contain any arrangement of objects. Lists have no limit to how large they can be or what kind of objects they can contain. They can contain literally anything. Deep down, pretty much all more complicated objects in R are actually just lists in disguise. So don't think too hard about that, but lists can be a collection of any object. Just know that. They can be ones, A, true, vector, C, works just fine. Lists can have names, so every element of this list can have a name. We can see now they've all got names. Now, when you access a list, you have to use these double brackets. And there's a particular reason I won't go into right now why you have to do that. But just know that unlike vectors, you got to use the double brackets. So let's look at the second element from this list, which is A. We can also use the names, again, in double brackets. You can also use the $sign. So can you tell me how to make a list that contains a list that contains a list that contains a data frame? So can anyone tell me the R code you would use to make a list that contains a list that contains a list that contains a data frame? I'll give you all a minute to do that one. All right. Anybody have any ideas on how you might do this? Give another 30 seconds. Okay, so let's make a list that contains a list. List. Oh, okay. Well, there you go. All right. So yeah, list that contains a list. Let's start with that one. So we've now got a list that contains a list. Let's do a list that contains a list that contains a list. And this is basically what Morgan was getting at here. List that contains a list that contains a list. And now we've got one that also contains a data frame. The one thing that I would do differently is I would open these parens at the end. And now we've got a list that contains a list that contains a list that contains a data frame. It's an empty data frame, but it's still a data frame nonetheless. If you take away these parentheses as Morgan has it, you can see here something interesting. Basically, this is a list that contains a list that contains a list that contains the function data dot frame. That's actually a function. So it's printing out the function here to make a data frame. But what we actually want is the data frame proper. So we have to actually execute that data dot frame function and make a data frame. 0 rows, 0 columns. All right, we're definitely not going to get to some of the more advanced stuff today. That's okay. We'll do it next time. Let's go ahead and wrap up here really quick with matrices and factors. And then I think that will probably be it. Yep, that will be it for today. We'll review the intermediate concepts next time and tidyverse next time, especially since we got kind of a late start. I think we'll definitely get a lot farther next time. We'll talk about the project then. All right, so before we wrap up, let's do the matrices and factors. And then we'll wrap up and take final questions here. First of all, matrices. Now, a matrix is just a glorified numeric vector. That's really all it is. It's just a glorified numeric vector. It can actually be a character, a Boolean vector as well, but we typically use numeric vectors for these. The way you can make one is you just say matrix, you give the numeric vector you want to make the matrix out of, and then you tell it how many rows you want and how many columns you want. By row equals true. Honestly, you're really rarely ever going to do this, so don't worry about what all this means at first. Honestly, most of the time you're not going to use these, but it's just good to know that they exist and what they are. If you're familiar with Python, this is sort of the equivalent of using like a NumPy array. Anyways, so we've now got our matrix, which is 1 through 10 numeric matrix with 2 rows, 5 columns. Really not going to use these very often, most of the time. Matrices can also have column names and row names. Yeah, they can be accessed basically the same way that data frames are accessed. The only difference is that when you look up here, it's got this slightly different looking thing here. If you click on it, though, you basically get the same thing. All right. You can also convert a matrix to a data frame fairly easily by using the function as.data.frame. And now it looks the same, but now it is technically a data frame instead of a matrix. Anyways, you can also have factors. Factors are very similar to vectors, except that they have labels and orders to the labels. So let's say that you have a factor that contains the vector 90, 80, 70, 60, and 0. Let's say these are the numeric grades in your American grading scale. All right, so we've got 90, 80, 70, 60, and 0. But we also see you've got these levels. What are these levels? Well, the levels tell you the primacy of the labels in your factors. So 90, 80, 70, 60, 0. Which of these comes first? Which of these goes last? Which of these is greater than the others? You can also have names in your factor. So A, B, C, D, and F. So this is, again, American grading scale here. So 90A, 80B, so on and so forth. You can get elements from your factor, but you'll notice that when you grab an element, it also grabs the levels. So it tells you where in the level of that factor your current element is, if you want to use it that way. You can also access the levels directly by using the levels function. If you want to change the levels, you can use that also using the levels function. Anyways, to be honest with you, I don't use factors very often. I consider them largely to be a nuisance. I also feel the same way about matrices, but some people use them and you never know, you might end up using them. So I'm not going to spend much time on them here though. All right, so I think that is plenty for today. The challenge problems are something I want you to begin now. We haven't reviewed a lot of the concepts, but you've done the data camp, so you actually have the knowledge required to complete them for the most part. So I would say go ahead, start going through these challenge problems. We will continue on next time with the part 2 of this, or with the second part of this review here. And what I'm expecting is that you'll have these challenge problems done before next week, because I think at that point, you really will be wanting to focus on the project itself that we're going to be doing. Okay. All right. So basically, a lot of these are fill in the blanks. Yeah. So I'll get to that in just a second. So first of all, we're going to be filling in the blanks here. So you want to correct this such that it works. You want to correct this such that it works. You want to fill in the blanks, Okay. Fill in the blanks, just read the instructions, go ahead and take a look at them, fill in the blanks, get it working. Now you've got some challenge problems here, some pretty hard ones at that. So this one involves converting between gene IDs and gene symbols. Don't worry if you don't know what those are yet. We'll talk about them. No worries there. But it's a common task to have to convert between them in bioinformatics or really in any sort of biological data science. So we're going to start doing that here. And basically, you'll see here how we create a function that allows us to do that automatically. And then we improve it over time. We use a CSV file that's involved in here to help us in that process. And it becomes progressively more and more difficult to the point where it basically becomes impossible. I call this by the end, you're at the give up challenge problem. This one's very hard. And then you get your degree now challenge problem, which is basically, it's actually one of the trainings that I give people when they're considering working on a real world research project to test whether or not they have sufficient R programming skills. If you can complete this, I will be extremely impressed. I mean, this is a very difficult challenge problem here at the very end. Basically, you create your own game of tic-tac-toe using nothing but R. Just to take a quick look at this here. Basically, you use only R and you create a game of tic-tac-toe that you can run using RScript tic-tac-toe.r. So this should be the name of your script. And you can see here playing interactively X or O, and you can see if you can beat the computer. All right. Anyways, that part's going to be really hard. I will be extremely impressed if anyone is able to do that before next week. Don't worry about like the challenge problems would be nice to finish. The ones that I think you really want to focus on though are these non-challenge problems. These are the ones that test your sort of basic ability to use R in a practical setting. With the challenge problems, see how far you can get, but especially once you get to like the extreme, the impossible, the good luck, the give up, if you just attempt your best. And if you're not able to complete it, don't get discouraged. We'll go through the answers. And it's really just something that's going to teach you a lot about R as you attempt to complete it. But I would say definitely try to get through the ultra challenge problem. Okay. All right. And if you don't feel ready to take these on yet, we'll be going through like for loops, if else, stuff like that starting next time. So wait till next time if you're feeling overwhelmed by some of the concepts that are in these challenge problems. And if you haven't, make sure that you do the data camp, right? The data camp is really, really important. Most of you did it, so that's good. But if you haven't done it, please go do that. You will struggle a lot if you haven't done it. Okay. So Giovanni asks, will the remaining lectures be online from here forward? Yes. Yeah, with the Delta variant the way it is, we're seeing breakthrough cases. We don't want to do it in person. Honestly, we just don't want to do it. But the other reason is because for these sort of workshops, doing it online is actually quite nice. You can see the screen a little bit more easily. And I think the next 3 lectures are all where you have a little bit more time to get from class to the lecture. This is really the only one where class was going to be ending fairly shortly before the lecture. So I'm pretty sure in the future it won't be as much of a logistical issue, but okay. So they will be online to answer your question. All right. Any other questions? Any questions? Any comments? All right, if not, then I will see you all on Friday. I'm gonna stick around. Me and Simon are gonna stick around and answer people's questions, but if you have any questions, you don't want to stick around, then we will see you all next time. All right, thank you all. All right.